video, I'm going to give you a solution method that the first evidence that was discovered. This solution method was attributed, as we've seen before, Bhaskara, but there's also another person, Jayadeva, that also had similar things as well. Anyways, I'm going to show you how, it's going to be an iterative, excuse me, it is going to be an iterative algorithm to find, starting with a Brahmagupta triple, to iterate an algorithm on that, to eventually get down to a Brahmagupta triple with x, y, 1. Okay, so I am going to I'm going to show you what the algorithm is, like the iterations in the algorithm, and then I'm going to do it with a specific example, like an example that's from the book, and then for homework you're going to do it for a fresh example. All right, so let's say we're going to start with a trivial triple, m1 m squared minus n. Convince yourself that that is a Brahmagupta triple, where n is the n in the x squared minus ny squared. Okay, so every step, what we're going to do is choose m, choose m such that x plus ym divided by k, so this is the k, so this is the x slot, this is the y slot, that's the k slot. Choose an m such that this is an integer. In other words, we want x plus ym to be divisible by k, and that minimizes the absolute value m squared minus n is minimized. Okay, then our new x is going to be x times m plus b times n divided by the absolute value of k. Our new y is going to be x plus ym divided by the absolute value of k, and our new k is going to be equal to m squared minus n divided by k. Okay, so let me just make sure that I got that written down correctly before I start doing this. Sorry, in my notes I have different letters, so this b should be a y. Okay, so xm plus yn divided by k, x plus ym divided by k, m squared minus n divided by k. All right. So I'm just going to warn you, this is going to be tedious to do, but way less tedious than just checking things. Just kind of randomly checking things. I'm going to illustrate the algorithm in this video, and then in the next video, I'm going to show you, give you an indication about why we would expect this algorithm to converge. That is, produce an output. Okay, so I am going to do it where n is equal to 92, so we want to solve the equation x squared minus 92y squared is equal to 1. I hope I don't make too many errors here. It's almost guaranteed that I'm going to make some arithmetic errors, but the good news is I actually wrote a program in Python to compute this, so I have everything listed out exactly as we need it. Okay, so I'm going to begin. I don't have a triple, so this is like the trivial triple. I get to pick what m is. I want to find the m that minimizes m squared minus 92. So I want to find the m that minimizes m squared minus 92. So that's going to be little m is equal to 10. So I'm going to have 10, 1, and then 100 minus 92. That's going to be my 8. So let's begin with the algorithm. So I want to choose m, and I don't think I mentioned it, but m needs to be a positive integer. I want x plus ym divided by k to be an integer. In other words, x plus ym needs to be divisible by k. So 10 is our x, plus y is 1 times m. I want that to be divisible by k. Excuse me. I want that to be divisible by k, and I also want it to minimize m squared minus n. Okay, so since m has to be a positive integer, the smallest a value here that I can pick is going to be 6. The smallest m that I can pick is going to be 6. Now, I don't want the smallest m. I want the m such that m squared is the closest to n. So if I choose m is equal to 6, I'm going to get 10 plus 6, which is 16. But m squared minus 92, yeah, and I'm using a calculator. I don't care. Is equal to minus 56. The reason I'm using a calculator is because I did not use a calculator, and I've been making this video now for like, I don't know, 20 minutes, and I've got like 3 minutes of usable time. All right, so that is m squared minus 92, 36 minus 92. Now the next thing that I could go here would be 14, because I needed to be a multiple of 8. So the next multiple of 8 after 16 is 24. So if m is equal to 14, 14 squared minus 92 is bigger than 100, so it's going to be even bigger than minus 56. So little m equals 6 is going to be my value of m, and now I can compute my values of x, y, and k. So x is going to be equal to my old x, which is 10, times m, which is minus 56. No, m is not minus 56, m is 6. And then plus my old y, which is 1, times my n value, which is always going to be 92 for this problem. And then I'm going to divide this by the absolute value of k. Here, k is just equal to 8. And you can do this for yourself and get that it's 19, but I want to double check. So 60 plus 92 divided by 8 gives me 19. Okay, that's my new x value. My new y value is going to be x, my old x, not my new x. We update these all at once. My new x, my old x, y, plus y times m. I mean, it's just this right here, plus 6 over 2. So this is 16 over 2. So that's equal, divided by 8. We divide by the absolute value of k, which is 8, which is equal to 2. And now my new k value is going to be equal to m squared. M is equal to 6. So this is 36 minus 92 divided by my old k, which is 8. And this is what we have. So it's going to be minus 7. This is minus 56 over 8, so we get minus 7. Okay, good. So we've got 19, 2, and minus 7. Good. That's like one iteration down, 6 to go or something like that. All right, so now we're going to do this whole thing again. So again, we want to pick an m such that x plus ym is a multiple of k. So this is 19, not 1. So we want 19 plus 2 times m. We want it to be a multiple of 7. Okay, and again, we want to minimize m squared minus n. Okay, so let's think about this. Well, if I pick m is equal to 1, this is going to give me 19 plus 2. That's 21. But 1 minus 92 is pretty big. Okay, so I'm probably not going to choose that one. Let me think about what the next value of m I need to choose is. So what needs to happen is 2 times m needs to be 2 mod 7 is one way that we can think about this. So if m is equal, if I do m is equal to 4, 2 times 4 doesn't work. If I do m is equal to 3, that's 2 times 3, that's 6, that doesn't work. If you do m is equal to 4, that gives you 8. 19 plus 8 is not divisible by 7. If you do m is equal to 5, you're going to get 19 plus 10, that's 29. That's not going to work. If you do m is equal to 6, you're going to get 19 plus 12, that gives you 31. Notice, let me just skip, if you do m is equal to 8, you're going to get 19 plus 16, which is equal to 35. So we're going to pick m is equal to 8. It's going to give us something that works here. So m is equal to 8 works here. And notice 2 times m That's 16 is equal to 2 mod 7, which is one way you can kind of think through these numbers a little bit better. Okay, so 64 minus 92, this one is equal to minus 28. That's what I was thinking about before, and when I say before, I mean the part of the video that I deleted when I made a wrong computation. Anyways, 64 minus 92 is equal to minus 28. Okay, now what's going to be the next value that I can think about? So the next value that I can, the next value of m I can pick is going to be way bigger than this, and this difference is going to be way bigger in absolute value than minus 28, or than 28. So I'm going to let you guys figure out what the next one should be and show that for yourself. Okay, so m is going to be equal to 8. So then our new x is going to be our old x, which is 19, times our m, which is 8, and then plus our old y, which is 2, times n, which is 92, and we divide all of this by the absolute value of our k, which is 7. And this is going to give us 19 times 8 plus 2 times 92 divided by 7 gives us 48. So our new x is going to be equal to 48. Our new y, well again we picked m, so that we've got 35 here. 35 divided by the absolute value of 7 is going to be equal to 5. And then we're going to have m squared minus n, so it's going to be minus 28. That's what our m squared minus n was. That's exactly what this is, m squared minus n, divided by k, not the absolute value of k, minus 28 over 7. This is going to give us 4. Okay. All right. So now we have we're going down. We went from I forget what our k value started off as. I think it started off as 8. Then it was minus 7. Now it's 4. So we see it's going down, but we're also see it's not going to go down monotonically. Okay, so that's one thing that's kind of disappointing. It does not go down monotonically. If it went down monotonically, then we'd be like, okay, we just have to do this 3 more times or something like that. But it's not going to go down monotonically, but it will go down. Now, for the homework, I'm going to ask that you stop here, and now from this, reduce this via a method similar to what we saw in the previous video, reduce this down to Brahmagupta triple of the form xy1. So it's going to save, if you do that, it's going to save a whole lot of steps. I'm going to do all of the steps just because I love doing tedious arithmetic on the whiteboard when nobody's around. Okay, so this is what we have now. You know what, I just erased all of our values for what we had. But luckily I have things written here. So x is equal to 48. This is equal to 5, and then we had 4. 48, 5, and 4 were our new values. Okay, so now we're going to go on to the next value. So again, I want 48 plus y, which is 5, times m. I want this to be a multiple of 4, and I want to get my m like as close to 92. I want to pick an m such that m squared is as close to 92 as possible. Okay, so let's think about this. 4 divides this, right? So I need this to be divisible by 4 as well. So 5 is not divisible by 4, so I need m to be divisible by 4. So if m is equal to 4, well, 4 squared minus 92, that's pretty big. But I could go up to 8 again. 8 squared minus 92, we've already done that one. And then if I go to the next multiple of 4, it's going to be 12 squared minus 92. That's 144 minus 92. That's going to be bigger than if I take m is equal to 8. So m is equal to 8. M squared minus 28, m squared minus 92. Well, 64 minus 92, this is going to be, again, minus 28. Okay, so now what's x? X is going to be our old x, which is 48, times m, which is 8, plus our old y, which is 5, times 92, and we're going to divide by the absolute value of k, which in this case is just k. So we've got 48 times 8 plus 5 times 92 is divided by 4. This is 211. So our new x will be 211. Y will be our old x, which is 48, plus our old y, which is 5, times our m, which is 8. And we're going to divide this by the absolute value of k. Okay, so this is 48 plus 40 divided by 4. This gives us 22. Okay, just wanted to check those values. And then if you compute k, well, k is going to be, we already seen this before. K is going to be equal to minus 28 divided by 4, which gives us minus 7. Okay, so this is going to be equal to minus 7. So we have a repeat value of k here, but we don't have numbers repeated here. So I have a repeat value of k, but we don't have values repeated here. What I mean is, we've already seen a k. We've already seen triples with minus 7 twice, but now we have 211 and 22 as well. Okay. Oops. When I say 211 and 22 as well, I mean the last time we had minus 7, it was 19 and 2 were the first two. Now we have 211 and 22, and these are like different. These are different Brahmagupta triples. They're obviously not just multiples of each other. Okay, so there. That's this one. So let's keep on going. You know, if I were you, I would probably start watching this video on like double speed now, at least, if you haven't already. Okay, m, we want x plus ym, so 211 plus 22 times m. Again, we want this to divide 7. We want this to be something. We don't want it to divide 7. We want it to be divisible by 7. We want 7 to divide. We want 7 to divide it. Okay, so I'm going to look for numbers such that m squared is close to 100, close to 92, and then see if those are going to work. Again, I could start from m equals 1 and work my way up. If I do 211 plus 22, 220, I get 431. If I divide that by 7, okay, so let's see. 211 plus 22 times 10 gives me 431. That's not divisible by 211 plus 22 times 9. Okay, so I got m, if m is equal to 6. Okay, if m is equal to 6, then this is going to be divisible by 7. And then remember that we've already looked at 36. 36 minus 92, that gives us minus 56. Now, if I want to look at m's bigger, again, you can by looking at m equal 10, 11, 12, so on and so forth, you can see that you're not going to get any difference better than this. Okay, m squared minus n is not gonna be any better than minus 56. All right, so now x, our new x is going to be our old x, which is 211, times our m, which is 6, plus our old y, which is 22, times our n, which is 92, and we're going to divide by the absolute value of k, which is 7. Okay, so we're going to have 211 times 6 plus 22 times 92. And then we're going to divide this by 7 to get 470. That's our new x value. Our new y value is going to be equal to 211 plus 2 times 6 divided by 7. 211 plus 12 is divided by 7. 22 times 6. 211 plus 22 times 6 divided by 7 is 49. So y is equal to 49. Then we're going to have minus 56 divided by minus 7. That gives us 8. Okay. So 8 is what we're going to have here. The new value that we're going to have here is 49. And the new value that we're going to have here is 470. Okay. Great. All right. So now next value, x. Sorry, I need to figure out what m is going to be. X plus y times m. So 470 plus 49 times m. I want that to be divisible by 8. Now, okay. And again, I want to choose m so that m is m squared is close to 92. I want to choose m so that m squared is close to 92. Okay. Hold on, I want to check this to make sure that I have not done anything wrong. Okay. So I do 470 plus 49 is 519. That is not divisible by 8. If I do 470 plus 49 times 2, that is equal to 568. So m is equal to 2 will work. Now that gives me a pretty big number, m squared minus 9. M squared 9, 4 minus 92 will give me minus 88. But as you can see, that's actually going to be the best number that we can do here. Okay, so there's not going to be a number that's closer. So m equals 2 is going to be the number that we're going to use. So x, our new x, is going to be our old x, which is 470 times our m, which is 2, plus our old y, which is 49, times 92. And we divide by the absolute value of k. So we're going to have 470 times 2 plus 49 times 92, and that is, divide that by 8, we get 681. Now y is going to be 470 plus 49 times 2 divided by 8. So we're going to have 470 plus 49 times 2, divide that by 8, and we get 71. And then we're going to have minus 88. M squared is 4. 4 minus 92 gives us minus 88, and we're going to divide by 8. That's going to give us minus 11. minus 11 there. This one we're going to get is 71. And this one that we're going to get here is 681. Okay. Very good. All right. So now we're going to do this again. Again, I want 681 plus 71 times m to be divisible by 11. So I want 681 plus 71 times 10. Sorry, 71 times m to be divisible by 11. And I want to maybe pick the m such that m squared is the closest to 92. Okay. All right, so let's see, 681 plus 71. Hold on, I need to make sure that my numbers here are also correct. Okay, 681 plus 71 times 2. Oh, you know what? I made a mistake. Okay, so m equals 9 is going to give us 681 plus 71 times 9 is equal to 1320. Okay, and that's divisible by 11. This is m correspond. That's the closest integer that we can get. 81 is the closest square to 92, and maybe you guys are thinking ahead. This is great news for us. So m is equal to 9, so x is going to be x times m. 681 times 11 plus 71 times 92 divided by 11. So I'm going to write, we will see this will be the last iteration. So 681 times 11 plus 71 times 92 is divided by 11. no, sorry, m is equal to 9. M is equal to 9. Okay, 681 times 9 plus 71 times 92 is divided by 11, gives us 1151. Okay. Okay, our new y is going to be this number here, 1320 divided by 11. 1320 divided by 11 gives us 120. And then finally, we're going to have 9 squared. Our new k is going to be 9 squared, which is 81, minus 92, over minus 11, and this is equal to 1. So now that is our Brahmagupta triple. This is a Brahmagupta triple, which will, with respect to this number 92. And in fact, what I mean by that, I just want to 51 squared minus 92 times 120 squared, that's equal to 1. You can put that in your calculator and check it. Now, yes, did this take an incredibly long amount of time? It did. Part of that is just because I'm standing up here at the board, and things take a longer amount of time when I'm, sort of doing arithmetic at the board and stuff like that. There's other little tricks that would have helped us find m faster. And like I said, there's one huge trick, one huge thing that Brahmagupta has. Whenever you have something where the third factor is either a 2 or a 4, I showed you how to do it for a 2 in a previous video. You can do something similar if it's a 4 and very quickly reduce everything down to having a 1 there. All right. Okay, I know that was an incredibly long video, but if the algorithm as described in the book wasn't quite clear enough for you, I hope this algorithm helped. It's a sort of variation of the algorithm described in the book.